Scholars, let's get started on our next set of independent practice questions and notes. For this portion, we're going to be looking at a concept called our equations expanded. Essentially, we're just seeing what our formula would look like if we modified it or modulated it slightly and moved our variables around. Important thing to be aware of here is just as if we had a set of like an algebraic equation where we had y plus 5 is equal to x, the same thing we can express as y is equal to x minus 5. Because of things like the transitive property, we know that we can move our values around and that the equations are essentially still the same. What I'd like to do is show you that variation, but with our circle formula. So if we take a look down at the paper here, what I'd like for you to do is put in your notes, your new next fresh page, circle of equations in expand. Or what you can call this as well is just another representation of the circle formula. So we have our original equation here, x minus h squared, y minus k squared is equal to r squared. In our previous lesson, we saw in terms of these particular values, hk is going to be the vertex of our circle. It's going to be the center point. X and Y are going to be the points that sit on the perimeter or like on the physical drawn circle itself. So the example that we're going to use right now is going to be the equation x plus 1 squared plus y minus 5 squared equal to 5 squared. So if we break this down, 5 squared is going to be 25. X plus 1 squared is the same thing as writing x plus 1 times x plus 1. Y minus 5, y minus 5. The reason why we're doing this is because we want to find, as we start to move to things like trinomials, we want to express out the quadratic form of our equation here. Okay, next point. Dealing with numbers inside the parentheses, to solve for this, we're going to do x times x and x times positive 1. So we get x squared plus 1x plus 1 times x, 1x, 1 times 1 is positive 1. Next portion here, y times y is y squared, y times negative 5, negative 5y, negative 5y, and positive 25. So, mentioned before, this equation right here technically is equivalent to our original one. If we were to put in all the same values, we would be able to express it in a very similar manner. But let's deduce some information down. Let's subtract our 25y over here. So now we have 0, we have x squared plus 2x plus 1, y squared minus 10y is equal to 0. And what I'm going to just do here is drop this one off on the side. Same thing though, all equivalent still to one another. So this is one format that you'll often see the formula written as. Another format that you'll see is like that r squared coming down. Instead of being 0, we'll have just a 1. So we'll have something like this. X squared plus 2x plus y squared minus 10y is equal to 1. So my question for you is, if this is the two different ways that we can represent it, and we put in the same we put in a value for x and y that are equivalent to our original equation, would you still get the same answer? If you were to put in the same values, you're going to get the same equation. It's that same idea as if we had y plus 5 is equal to x, would still be, the equation would be y is equal to x minus 5. All we have to do is just slide those values over. That's what we're taught in algebra in terms of just subtracting that minus 25. We're still going to have the same values. Next, what we can do here is let's test. Let's just do a test. Let's check our work in a sense. So if we're going to check this, we can use the same point in both equations. The point that we're going to use right now is going to be negative 4, comma 1. And we're going to just punch this value into our two equations here. So let's try this. We'll do following this little line here. Do negative 4 plus 1 squared plus 1 minus 5 squared equal to 5 squared. So we're pushing in our values for our original equation here. If we reduce everything down, we're going to have 3 squared or 9, negative 4 squared or 16, 19 plus 16 is equal to 25. Okay, so that's if we put in the values of x and y, our vertex portions, into our original equation here along the top. What I'm going to do now to check or to verify if these two equations work, the claim that I stated before, is just put in the values again. All right, so if we're going to take this representation of the equation, the one with our plus 1, we'll have formula like this. Now we're just going to go ahead and substitute our values in, our negative 4 going into our x values. All right, so let's put some information down here. If we combine all of our values here, 16 minus 8 gives us a positive 8. 1 minus 10 gives us negative 9. Plus 1 gives us negative 8. 0 equals 0. And essentially we can prove that if we modulate, if we modify our equation, there's multiple representations thereof. It doesn't have to be just in this one individual sequence. So what we're going to do now is if you go to your another piece of paper, we're going to take a look at quadratics, or how quadratics function. As we saw in the previous section, there's multiple ways that we can express the equation of a circle. Our original form is along the top here, where we have x minus h squared, y minus k squared equals r squared. In the previous section, we just saw how we can manipulate our variables and express them in different ways and create what's called the expanded form. What we're going to do now is basically move backwards using quadratic equations to figure out how to locate our x variable, our y variable, our k and h in case our numbers are moved around. This methodology, once again, is going to be using quadratic equations. So if you are uncomfortable or unfamiliar with them, please go back into our Google Classroom assignment and click on the video for quadratic equations, and you'll be able to hopefully quickly follow along. In addition to that, I'm going to be able to supply some extra notes for you. Your content's going to look a little bit more detailed. We're going to start with setting up an example equation, and then I'm going to notate how to be moved backwards doing all of these different steps. So the right side of your page, you'll want to maybe set up a slight column, grab a couple colored pencils. We're going to take our notes down here, like as if we were listening in class, and then on the left-hand side, we're going to write down the specific equations. So first thing we're going to do is use our sample equation for this portion of our notes, which is going to be x squared plus y squared minus 2x plus 6y plus 3 equal to 0. All right, okay, so we're going to have our left and our right side for our column of paper. This example here is just going to be the equation we're going to be provided. And our first step that we're going to do is we're going to reorganize the variables that are in line here and place them into what's called x and y order. Essentially, we're going to have x squared minus 2x, y squared plus 6y. We're going to pair them together. And what you're also going to do is take that just open general number and move it to the right side of the equation. So we'll have something that looks a little bit like this. X squared minus 2x plus y squared plus 6y. And I'm going to say, I'm going to put my equal sign a bit off to the right side, just so you'll pick up on it in just a second. So we're going to move, if you can't see, our 2, we're going to place it right next to the x squared. Our 3, we are going to move over to the right side of our equal sign by subtracting it. First step we can notate as is to order x and y variables together. This is going to allow us to complete our next steps in a little bit easier fashion. It also makes it a little bit more reminiscent of up top here, or our previous expanded form examples. Our next step is we're going to find what we're going to call our b values. Our b values are going to be the digits located in front of our x. Not the x squared, but just the plain old x and the plain old y. So I'm going to use another marker. I'm just going to highlight our -2, highlight our +6, and update our notes for find our b values. We're going to have what's called b1, and that's going to be the number in front of x. b2 is going to be the number in front of y. The reason why this is important is because for our third step, we're going to be adding some values to our equation. One thing to take in consideration, if we're going to add, say, the number 1 or the number 9 to the left side of our equation, we're going to do so on the right-hand side. The reason why we're going to be adding a number is we're going to, in our successive steps, create a trinomial. Those examples where you see like x squared minus 2 plus +1 within our parentheses, those are trinomials where you have 3 different factoring numbers. Third step here, the way that we're going to get the number we're going to add is we're going to take b1 divided by 2 and square it, and we're going to take b2 divided by 2 and square it. So if we take the number -2 divided by 2 and then square it, what do we get? For this particular one, we would have an answer of positive 1. If we take negative 2 divided by 2, which gives us negative 1, and we square it, we're going to get a positive 1. Just update your colors here. Your second, as we saw, was our red. Our blue was our first, just to keep nice and consistent here for you guys. The next portion we're going to have here is going to be y squared plus 6y plus 6 divided by 2, which is positive 3. Positive 3 then squared gives us a value of positive 9. Just as a reminder here, also, what we need to do is add these values to the left side. So we're going to have negative 3 plus 1 plus 9. And don't forget to add this to both sides of our equation. Cool. Next. This is when we have to remember how to do our factoring for trinomials. Our fourth step, we are going to look to factor a perfect square trinomials. And the steps to do this is we have to think about what number times what number equals what we'll call the letter C as it's normally expressed. C is going to be those integers, we add it. So what number times what number equals C, but in addition, adds up to our B value. And B, once again, is our red number. So you have to think about what number times what number equals 1, but if we add it together, equals negative 2. So the way that we would go about expressing this, x minus negative 1 times negative 1 gives us positive 1, but also if we add it together, negative 1 plus negative 1 gives us negative 2. Three times 3 gives us 9, but 3 plus 3 gives us 6. If we add all these values here, 10 plus negative 3 gives us positive 7. Last thing we're going to do here, color code for step number 4. The reason why we're doing all this is because we're taking our expanded form equation, like we saw in our previous portion, and now converting it back to our standard equation of a circle. Okay, so that's it in terms of this part. The only last thing we need to do now is just locate our values. Based upon our original equation, we have x minus h, y minus k. Down here, we're basically just going to say that negative 1 is going to be equal to our h value, or that point on the circle. K is going to be the y value of the point on the circle. The last thing here is going to be our radius. Our radius is going to be equal to the square root of 7. You see in the equation here, it's r squared. If we want to find just plain old r, it's going to be radical 7, where the value of r squared would be 7. So we're going to go with nice purple here to mark down everything. And the last thing I would like for you to add to your notes is just to don't forget to find the square root of the letter R. As a suggestion, I would leave it just as such. Under the radical, oftentimes you'll see you will have to square that number again. So if you end up putting radical 7 into your calculator and getting a very small decimal, that depending upon how you write that particular number down, as you go down the road and re-enter that value in, so as opposed to having 3.14567891 and you have just 3.1, those two values are going to end up being a bit off when you do your calculations again. So just leave it under your radical, stay radical 7, and it'll be perfectly fine. Now we are going to test an example of this. We're basically going to complete a similar type of question, moving all of our pieces around, and then when we get to the end, we're going to verify if a particular type of particular point is going to work with the equation that we generated. Our first step that we're going to take, once again, is we are going to move our values around. Our first task is to reorder our x and y on the left or the right side, typically the left side, but we're going to put them in that x squared minus x format, y squared minus y format. So we're going to move these two values over to our left side. We're going to have x squared minus 4x minus y squared minus 12y equal to 9. Next step is going to be finding our b value. Our b values are going to be negative 4 and positive 12. Next thing we're going to do is locate our b values, divide it by 2, and then square it and add it to both sides of our equation. In this particular one, we're going to have x squared minus 4x, negative 4 divided by 2 times 2. So negative 4 divided by 2 gives us negative 2. Negative 2 squared gives us positive 4. 12 divided by 2 gives us 6. 6 squared gives us positive 36. And then we are just going to add those two b values on the right-hand side of our equation to balance everything out. If we add something to the left, we have to add it to the right to keep it equal. Next piece is going to be step 4. Within step 4, we are going to factor out our perfect trinomials. Our two steps for that is going to be we have to figure out what number times what number gives us our change in values here. So if we're going to take positive 4, what number times what number equals positive 4, add them together equals negative 4. In this particular example, we're going to have negative 2 times negative 2 gives us positive 4. Negative 2 plus negative 2 gives us negative 4. On the right side, for our y squared, 6 times 6 gives us 36. 6 plus 6 gives us positive 12. And all of these values here combined are 49. We want to go ahead and verify if these values are correct, or if we have a point that we want to see is on the line or not on the line of our circle, on the perimeter, if you will. Basically, we just punch in these values. We have to do a couple things here. First, we know that in this particular example, we're going to have -2 and 6 is going to be our center point, and 49 is our r squared value, and just plain old r is 7. If we're going to test the value of 0, 1, just going to take the equation here and place in the value of 0 and 1. So if we go ahead and rewrite our equation, I'm going to input our values here, and then check to see if they are equal to one another on the left-hand side of the equation. -2 squared gives us positive 4. 7 squared gives us positive 49. And we check to see if they are equal, and they're not equal. So 0, 1 is not a solution. What I'd like for you to do now is, once we finish up our notes here, is I want you to go into Google Classroom, and within Google Classroom you'll see listed under assignment for today an independent practice. Within that independent practice, there's a handful of questions I would like for you to complete, and once you finish completing them, I would like for you to take a picture of them or scan them into your computer, and in Google Classroom submit that file. For today, we have 2 different independent practice sessions, so you should be submitting 2 different independent practices. Please make sure that on your paper that you're going to write out the actual independent practice you have. If you have a whole bunch of papers, please in the top corner say page 1 of 2 or something like that, just so I can keep track of everything. What would also be really helpful is if you have your name written on it as well, too, just in case. If you do have questions about any of this material, I have my office hours available from 1:30 to 3:30 pretty much every single day. What you'll have to do to gain access to office hours, you have to email me, and I can send you the password for that day's office hours. In addition to that, just as a reminder, for those of you who do not start your work early in the morning, if you're just going to pop into office hours, I'm going to check to see if you've watched the Edpuzzle video, like this video here, before you actually go ahead and start asking questions. Please watch the videos. It takes a long time to record them, and I try and make them as detailed as possible for you. In addition to that, if you're having questions on your work, please feel free to email me. But if you're going to be emailing me at 9, 10, 11 o'clock at night, probably not going to get an answer. So please do your work early in the day, so then you can hop into office hours and get the most out of me as possible. But as well, if you ever need help, please just let me know. All right, have a nice afternoon, and goodbye.